Hi, my name is Josh Mack, and this is my VoiceThread 1 for Math 122 Pre-Calculus. Today I will be explaining what a function is and what are the four ways to represent a function. So a function is basically just when one quantity depends upon another. So for example, an easy one would be um, the f of x equals x minus 1. So the f of x, or y, equals x minus 1. And all that's telling you is no matter what x is, so let's say, for example, x is 5, y is going to be 1 less than that always. So it's completely dependent upon what the x value is. I like to call it y a lot of the times. It makes it a little bit easier for me because I know that y is associated with the vertical axis, where the x is associated with the horizontal. An example would be the rate at which my vehicle burns fuel is completely dependent upon the rate at which I accelerate the vehicle. So the f of x, the rate at which my vehicle is burning fuel, is going to be based, again, to repeat myself, off x, which is the rate at which I'm accelerating. Um, and that just is to show you that one is completely dependent upon the other. The book defines it as a function, or f, is a rule that assigns to each element x in a set, so set A, exactly one element called f of x in a set B. So in my example, set A was the rate at which my vehicle burns fuel, and that was dependent upon B, which is the rate at which I accelerate. So one of the diagrams I liked was the machine diagram in the book. It just had an input coming in, and then based on the formula that would be in there, you know exactly what your output is. It just helped me. The four ways to represent a function is there's verbally, algebraically, visually, and numerically. So verbally is by description. So basically, I'm stealing a lot of these from the book, Celsius to Fahrenheit. So you get Celsius, you multiply it by 9/5, and then you add 32, and you're going to get your Fahrenheit equivalent. And then there's algebraically, so by an explicit formula. So the area or radius is equal to pi of radius squared, and that's just showing that everything is very dependent upon the radius of that formula. And then there's visually, so by graph or any statistic ever. So you can see f of x, right? Put y underneath it, the gas burning and the rate of acceleration. And then there's going to be numerically, which is a table of values basically. So the cost of mailing a letter, so the one that the book used, where the weight is associated with the price, and it's the same thing for food. When you go to a grocery store, you're gonna, depending on how much weight, how much the food weighs is depending on how much you're going to pay. So this concludes my voice thread for week 1, and please let me know if you have any questions.